In chapters 3 and 4, we do correlation and regression. So in chapters 3 and 4, we have two variables, x and y, and we find the relationship between x and y. So first, data are collected. So that's our first step. If we think that there's a relationship between two variables, x and y, we collect data. For every x, we collect a y. And our second step is we make a scatter plot. And we plot the xy pairs. And this is what we have. We have the explanatory variable on the x-axis and the response variable on the y-axis. The reason why we plot the graphs is to plot the scatter plot is to find a pattern. And when we see something like this, we see an overall pattern of a straight line. So if the pattern is a straight line, if it is a straight line, we call it a linear pattern. If it is linear, then the next step is to calculate the correlation coefficient. And the letter that we use for the correlation coefficient, which is R, a number. So R is a number between -1 and 1. And what R does is it describes the strength of a linear relationship. Remember that the relationship has to be linear before we calculate R. R is appropriate as a numerical summary only if the relationship is linear, only if we see a linear pattern, either positive or negative. So once we calculate R, R gives us the strength of the linear relationship, a relationship that we have established is linear from the scatter plot. If we want to know the strength of that linear relationship, then we calculate R. So R could be anywhere between 0 and 1 for a positive relationship, and it could be anywhere between -1 and 0 for a negative relationship. The closer it is to 0, the weaker is the relationship. For strong relationships, we want it to be closer to either 1 in the case of a positive relationship or -1 in the case of a negative relationship. So a numerical summary, a summary doesn't have to be a bunch of numbers. R is a single number that describes the strength of a linear relationship.